Okay, so we're up to chapter 9 of Introduction to Networks. So address resolution protocol. So we're going to explain how ARP and ND, which is neighbor discovery. So ARP is IPv4, neighbor discovery is IPv6. Now, basically, we're going to look at both MAC and IP addresses. We're going to then we'll look at ARP and how that's used to discover MAC addresses typically, and then neighbor discovery, which basically does the same thing, but no broadcasts. Okay, so MAC and IP addresses. So there are two primary addresses assigned to a device on an Ethernet LAN. So there's a layer 2 physical address, the MAC address, used for NIC-to-NIC communications on the same Ethernet network. And then there's a layer 3 logical address, the IP address, used to send packets from source to destination. Layer 2 addresses are used to deliver frames from one NIC to another on the same network. If the destination IP address is on the same network, the destination MAC address of that will be that of the device. So here we're talking about host 10 and host 11 on 192.168.10.0. And so as you can see, the destination MAC address is all the 5s, and the source address was all the A's. So when the destination IP address is on a remote network, the destination MAC address is that of the default gateway. I think I've covered this a few times. ARP is used by IPv4 to associate the IPv4 address from a device with the MAC address of the device NIC. ICMP-v6 is used by IPv6 to associate an IP address of a device with the MAC address of a device as well. All right, so we'll talk about ARP. So a device uses ARP to determine the destination MAC address of a local device when it knows its IPv4 address. And so it provides two basic functions. It resolves IPv4 addresses to MAC addresses, and it maintains an ARP table. So I think last week I actually got you to type in ARP-A. That shows you all entries in the marked ARP table. That's what the A stands for, all entries. Now, to send a frame, a device will search its ARP table for the destination IPv4 address and hopefully find an entry with the corresponding MAC address. If the packet's destination IPv4 address is on the same network, the device will search the ARP table for the destination IPv4 address. If the destination IPv4 address is on a different network, the device will search the ARP table for the IPv4 address of the default gateway. If the device locates the IPv4 address, its corresponding MAC address is used as the destination MAC address in the frame. If there is no ARP table entry found, then we need to do an ARP request. So, entries in the ARP table are not permanent, are removed when the ARP cache timer expires after a specified period of time. The duration of ARP cache timer differs depending on the operating system. Often think about 5 minutes, I suppose, something like that. The ARP table entries can also be removed manually by the administrator. Okay, so now on a router, you can type in show IP ARP and it will give you the entries. And so at the moment, we've got 192.168.10.1. I'm assuming that's its own interface, and that would be its MAC address. And that is the interface we're talking about. And so if we look at a Windows machine, as I said, it's ARP-A. We've got two entries for 1.1 and 1.101. They're not on the same network. Anyway, I was really hoping to be able to see that MAC address in here. But anyway, this is 10.1 and this is telling us about 1.1, so it's a different router. And so you can see that its type is dynamic. Now that means it was learnt either by communicating with that host or by an ARP request, basically. Here, there is no age here. So it basically will tell you how many minutes it's got to go until that entry will be timed out. But because it's its own local entry, it doesn't need to time that out because, hey, it's itself. All right, so ARP requests are received and processed by every device on the local network. So excessive ARP broadcasts can cause some reduction in performance. ARP replies can be spoofed by a threat actor to perform an ARP poisoning attack. Enterprise level switches include mitigation techniques to protect against ARP attacks. Now, basically, we're getting into security already and also other issues. So broadcasting is bad. When you send out a broadcast, every host will need to deal with that, whether it needs to or not, because that's just the way they are. If they're talking IP, they will deal with that broadcast. When it comes to neighbor discovery, when we talk about that a little later, IPv6 does not use broadcasts. I think I may have already said that. It actually uses multicasts. And the advantage of multicast is it can actually deal with more of it in the NIC than you can with a broadcast. A broadcast will always go into RAM and will always be dealt with by the local CPU. So that's not always good. I'm going to say if a multicast is destined for you, that will happen as well. But if it's not destined for you, it actually will completely ignore it at the NIC level. Okay, copper cabling. Why is that say copper cabling? All right. IPv6 neighbor discovery, apparently. So, but it didn't actually explain the ARP process at all. Anyway, so with an ARP request, basically, you know the destination IP address through DNS probably. And then, of course, you need to learn the MAC address. And so basically, if you don't have it in an entry in your ARP table, you send out a broadcast. So the destination MAC address is all ones. The destination host address, as in IP address, would actually be the one that we know it's IP address. And so you send it as a broadcast for the MAC, so the destination is all Fs, but the destination and IP would be whatever host you're trying to learn. So if it's the router, 192.168.10.1. And so then basically all hosts will see it and pass it up to IP, but IP will go on all the hosts that aren't 10.1, will go, I don't care about that, that's not me. While the host that is 10.1, assuming it's the router, it will actually go, oh, someone wants to know my MAC address. And so after the ARP request, there is an ARP reply saying, all right, well, hey, my MAC address is XYZ, whatever it might be. Of course, it's not going to be XYZ, but anyway. And so that's how it learns the destination MAC address. All right. This is not copper cabling. This is IPv6 neighbor discovery messages. So neighbor discovery allows you to have an address resolution, router discovery, and redirection services. Now, neighbor solicitation and neighbor advertisement messages are used for device-to-device messaging, such as address resolution. So basically, when you want to talk to a host on the same network, you actually send out a multicast to all IPv6 hosts, and you say, hey, who has this IPv6 address? And then the response will be much the same, but it's a multicast instead of a broadcast. Now, so ICMP v6 router solicitation and router advertisement messages are actually used to discover who your router is on your network. And then redirect messages are used by routers for better next hop selection. Now, the next hop selection is basically if you've got a subnet with more than one router on it, that's all very nice, but you can normally only ever configure a host with one gateway address. And so what that does with a redirect address, and it's actually there are redirect messages in ICMP version 4 as well, is it says, when you're going for such and such destination, hey, use this as a next hop instead of me. So basically, if you send it to your default gateway every time, if it actually needs to go out the other router, that router will actually have to send it to the other router and then go out. And so that redirect says, well, just send it straight to that other router. But that's only if you've got two routers plugged into that subnet that it's useful. But anyway. All right, so neighbor solicitation. So IPv6 devices use ND, or neighbor discovery, to resolve MAC addresses of a known IPv6 address. So neighbor solicitation messages are sent using a special Ethernet and IPv6 multicast address. And so basically, you send out, who has this address? Tell me your MAC address, please. And so the end result is the same as ARP, but it's a slightly different process. And so, of course, the host will then reply with that information. So it's much the same process, just different because they're trying to get rid of broadcasts. Okay, so what did I learn in this module? So layer 2 physical addresses are used to deliver the data link layer frame with the encapsulated IP packet from one NIC to another NIC on the same network. If the destination IP address is in the same network, the destination MAC address will be that of the destination device. When the destination IP address is on a different network or remote network, the destination MAC address will be the address of the default gateway. An IPv4 device uses ARP to determine the destination MAC address of a local device when it knows its IPv4 address. ARP provides two basic functions. It resolves your IPv4 addresses to MAC addresses and also maintains that ARP table. After the ARP reply is received, the device will add the IPv4 address and corresponding MAC address to its ARP table. For each device, the ARP cache timer removes ARP entries that have not been used for a specified period of time. IPv6 does not use ARP, but it uses neighbor discovery, or ND, to resolve MAC addresses. So the end result is pretty much the same. An IPv6 device uses ICMPv6 neighbor discovery to determine the destination MAC address of a local device when it knows its IPv6 address. Now, we will go into more depth into neighbor discovery and router discovery when we actually talk in more depth about IPv6. So we haven't really, it is in a chapter, just not yet. So there is more to come. So if you're a bit confused about IPv6, don't worry. We will have a chapter on it and it will all be good, hopefully. All right, so there's the logo. So that was chapter 9. And I've obviously got to edit at least one slide. All right, so that's it for today for that. So, yeah, have a good one.